Hello, we're going to be reading this article and the one that follows it as well. And I was going to try to highlight the things I'm reading, but we'll see if that works. Well, it's white, so the highlighting doesn't really do much. Well, here we go. Mendeleev and his periodic table, Lexile 740. Russian chemist Dmitry Mendeleev knew scientists needed to be able to identify an element easily. Earlier scientists had organized elements. Their tables, however, did not satisfy Mendeleev. He felt they had left out important information. Early in his career, Mendeleev studied the chemical and physical properties of the elements. He saw patterns in the properties of some elements. Using these patterns, he organized the elements in a logical way. He designed the periodic table of elements in 1869. This table put elements in order by increasing atomic mass. Groups of elements were put into rows and columns based on similar physical and chemical properties. The table later proved to be a bit flawed. Mendeleev, however, had expected this. He left some blank spots on his table for undiscovered elements. These were, indeed, found later. His table also did not show how important protons are. They had not been identified yet. Protons are important in grouping elements since they strongly influence the physical and chemical properties of elements. The table also did not have a place for the noble gases. These elements do not have properties like those near them on the table. Today's periodic table looks much like Mendeleev's table of 130 years ago. More elements have been identified and classified. The inert gases now fit into the table. The table is now put in order by increasing atomic number rather than by increasing atomic mass, like Mendeleev's. It shows each element's physical and chemical properties. The periodic table of elements remains a valuable tool for chemists and other scientists. All right, let's look at the questions. Number 1, Mendeleev organized his periodic table by blank, in the same way that today's periodic table is organized by atomic number. The choices are protons, neutrons, atomic mass, or atomic number. Number 2, the modern periodic table is different from Mendeleev's in several ways. In which way are the two tables the same? A, the inert gases occupy one column of the table. B, elements are arranged by increasing atomic number. C, there are blank spots in the middle for undiscovered elements. D, elements are put into columns based on similar chemical properties. Number 3, Mendeleev's periodic table lacked A, noble gases, B, inert gases, C, neutrons, D, atomic mass. Number 4, how does the periodic table used today classify elements? A, according to chemical properties alone. B, according to atomic number. C, according to atomic mass. D, according to radioactive properties. The diagram above shows a portion of the periodic table. Elements which were unknown during Mendeleev's time have been removed. So he didn't know about them. Using Mendeleev's rules for arranging elements, which box would contain the metal gallium, which has an atomic number of 31 and an atomic mass of 70? So it's important that you see that it says using Mendeleev's rules for arranging elements. All right, so we're moving ahead, and make sure that if you need to pause to find one of those answers, you do that. All right, we're reading the history of atomic theory, Lexile 820. Since ancient Greek civilization, People have wondered about the nature of the atom. The atom is the basic building block of matter. The word atom comes from the Greek language. A is a prefix meaning not. The word tomos means cut. Therefore, atomos or atoms means cannot be cut or divided. Many people helped develop the theory of atoms. The first was a Greek named Democritus in the 4th century BC. He proposed that all matter was made of tiny particles. Democritus thought that empty space filled the area between the solid atoms. That concept of the atom was unchanged for centuries. Then, an English scientist, John Dalton, proposed an atomic theory in 1803. Atomic theory says that atoms are solid with an atomic mass. They can react because of the forces of attraction and repulsion. In 1873, James Clerk Maxwell proposed that electric and magnetic fields filled the empty space in atoms. In 1897, J.J. Thomson discovered the first subatomic particles, which he called electrons. His experiments found that these electrons have a negative electric charge. He then calculated that they had a much smaller mass than even the smallest atom. Thompson, proposed the plum pudding model of the atom. That's what this picture here is about. This model says that negatively charged electrons are mixed inside a cloud of positive charge. He thought they were like chunks of plum inside pudding. So they're saying those are the electrons. All right. Ernest Rutherford did an experiment in 1909 to test Thomson's model. His results did not agree with the plum pudding model. Instead, Rutherford was the first to show the nuclear model of the atom. This model shows that the center of an atom contains positively charged protons surrounded by the negatively charged electrons. In 1932, Sir James Chadwick found the neutrally charged neutron. The atomic model now seemed complete after all these discoveries. Many people had a hand in developing atomic theory as we know it today. However, scientists continue to study the atom. They have found many more details about atoms. As we learn about this building block of matter, the nuclear model of the atom will continue to change. Questions. Number 1, the root word di means two. So the word diatomic, refers to, and your answer choices are A, forces within the atom, B, a molecule with two atoms, C, negatively charged electrons, and D, positively charged protons. 2. In paragraph 2, attraction and repulsion refer to A, electric and magnetic fields, B, atomic theories, C, tiny particles, D, solid atoms. 3. How did Ernest Rutherford's experiment relate to J.J. Thomson's work? A, Rutherford looked for magnetic fields while Thomson looked for electric fields. B, Rutherford repeated Thomson's experiment and confirmed the results. C, Rutherford tested a conclusion based on Thomson's results. D, Rutherford had not known about Thomson's experiment. Number 4, which experiment discovered the neutron and gave us the current basic model of the atom? A, James Maxwell. B, John Dalton. C, James Chadwick. D, Sir Isaac Newton. Number 5, what contribution did J.J. Thomson make to the development of atomic theory? A, said that atoms are solid masses. B, showed that electrons surround a dense nucleus. C, found that atoms are made of smaller particles. D, proposed that atoms contain electric fields. That's all. Time to stop the recording.